US Air Force. Men's heights are normally distributed with mean 69.5 inches and standard deviation of 2.4 inches. Women's heights are normally distributed with mean 63.8 inches and standard deviation of 2.6 inches. The U.S. Air Force requires that pilots have height between 64 inches and 77 inches regardless whether they are male or female. Find the percentage of women meeting the height requirement. We can answer this question by finding the probability that women meeting the height requirement, which is between 64 and 77 inches. Since the height of women are normally distributed, we would first draw the normal curve. This is for the woman's height only. We label the mean for woman's height 63.8 inches and the standard deviations of 2.6 inches. The woman would meet the requirement for a U.S. Air Force pilot if the height is between 64. 64 inches is greater than 63.8, so we would draw the vertical line and label 64 on the right hand side of the mean 63.8. And we also label 77. Draw the vertical line, label 77. Anything in between would meet the requirement. We're looking for the probability that 64 is less than x, less than 77. With the continuous normal distribution, whether we use less than or equals, it doesn't matter. To compute this probability, we would use the normal calculator with StatCrunch. With StatCrunch, there are two values that we are interested in the probability, 64 and 77. So we would have to choose the between feature, which is in the upper left corner. Once we choose between, there should be two boxes where x is between. We then input the values for the mean and the standard deviation. For woman's height, the mean is 63.8 and the standard deviation is 2.6. Make sure you clear out the box before you input these values. The two x values that we are interested in are 64 for the lower limit and the upper limit is 77. And so we're looking for the probability that 64 is less than x and is less than 77. Once we input everything, we can hit compute. StatCrunch calculator will then give us the probability of 0.4693, rounded to 4 decimal places. And so the answer is simply 0.4693. The proportion or the percentage in this case is 46.93%, or roughly 45% of the women would meet this Air Force requirement. Next, find the percentage of men meeting the requirement. With the men, they have the different distribution. So to answer this question, we would also need to draw the normal curve for the men height. The mean is 69.5 and the standard deviation this time is 2.4. The requirement are the values between 64 and 77, but this time 64 is less than 69.5, so it is on the left hand side of the mean, and 77 is on the right hand side of the mean. We would then shade everything between 64 and 77, and then we use the StatCrunch calculator. Again, there are two values in this probability, so we would need to choose the feature between in the upper left corner. Input the mean. This time, the mean is 69.5, and the standard deviation is 2.4. Clear the box if there are anything in the boxes. The lower range is still 64 and the upper is still 77, and then we hit compute. The corresponding area or probability is 0.9881. And so for the men, the probability that 64 is less than x is less than 77 is 0.9881. What that means is that roughly 99% of the men would meet the height requirement in this case. If the Air Force height requirements are changed to exclude only the tallest 3% of men and shortest 3% of women, what are the new height requirements? What this means is that we need to find the height that would separate the tallest 3% of men, and we also need to find another height that would separate the shortest 3% of the woman. Using the same normal distribution for the men and the women, it is best to not draw one on top of another, so we would draw a separate bell-shaped curve for the men, label the mean 69.5 and the standard deviation of 2.4. This time we are not given the height, but we're given the top 3%. That means we're given the area, the probability, and 3% is 0.03. We're looking for this x value. We will use StatCrunch normal calculator to do so. Similarly, for the woman, we would draw another bell-shaped curve, label the mean height for woman 63.8 given in the problem, and the standard deviation is 2.6. For the woman, we want to exclude the shortest 3%. So the probability on the left-hand side is 0.03. And we're looking for this corresponding x value. With each of the x values, we would use the different mean and the different standard deviation. Using the standard normal calculator, we would choose the features that standard on the upper left corner because there is only one x value that we're looking for. The mean is 69.5, the standard is 2.4. Since we're given the area on the right hand side or the tallest, we would choose the inequality greater than or equals, but then we would need to leave the box inside the parentheses empty, so clear it out if there's anything in there. The area on the right is 0.03. Input 0.03 in the box after the equal sign and hit compute. The given height is 64.01, so we will round it to 64. The number that separates the top 3% or the tallest 3% of men height from the remaining is 74 inches. We then do the same for the woman distribution with the mean 63.8 and the standard deviation of 2.6. This time the inequality has to be less than or equals because we're looking for the bottom or the shortest 3%. Leave the box inside the parentheses empty. The area given is 0.03. Input 0.03 in the box after the equal sign and hit equals. The calculator will give us 58.91. We round it to 59. And so the height that will separate the bottom or the shortest 3% of the woman height is 59. What that means is that putting these together, we see that the new standards are the height between 59 inches and 74 inches.